Okay, that's great. So looks like I came very close to the computer, and that is the reason that might be it starts doing that. So now I should stay a little bit far from the machine. So please let me know if you hear me well, because I am sitting now a little bit far from the computer. Okay. So now we are saying that if this is the case, uh, when we talk about any English language, so we have the letters. From the letters, we make words. From words, we make sentences, and from sentences, we make essays or some whatever we want to make. Okay, so we have the same concepts. So we have alphabet here, and each single uh, Uh, so the set of so what is alphabet is a finite set of symbols, and how you know that these are alphabets? You will see so alphabet is basically a set here. Okay, so you will see summation, summation sign, and then you will see one set here. So let's say A, comma B, comma C, and this is it. So this is your alphabet. All this thing, these are your alphabets. Okay, so when I say summation, when I say alphabet, so you need to understand I am talking about the summation. Okay, and this is always be a set of alphabets. Each single member of this set is called letter. So now in this, A is letter, B is letter, C is letter, and whole this thing is called alphabet summation. And now you combine these letters and these which you get from this alphabet, and you make a word. So if you see the definition of the word, so this is your alphabet, this is your letter, and then what is word? A finite sequence of letters from the alphabet. So now you are saying I have a word which is composed of two A's, let's say. So I can reuse my letter from, but all those letters should be part of this summation, this alphabet. And I make a word which does not have any B or C, which is just two A's. Or let's say I have a word which is A and then B, 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 and whatever after that. Okay, I have a word which starts with B, and I don't care what come after that. Might be C, might be again B, might be A, or as many times, but always start with B. I have a word which is start from A or B, or it is A B. So any combination of letters from the summation, which is your alphabet. So this will be a word. Okay. Then we have this lambda, which is it is called an empty string. Okay. So a word without letters. So lambda is not a letter. It's not. It's a. It's a. It's a. It's an empty string. It is a word. Okay. So now, if you combine these letters, you will make a word. This is your word. This is your word. Now, lambda is also your word. But this word, so now when we say word, word is composed of letters. So now if I say I have a word A, B, B. So now I can say that this is my word. It is composed of three letters A, B, B. But lambda is your empty string. It is a word, but this word does not have any letter. Okay, so you just see lambda, so it means that it means that this is a first of all, this is not a letter, this is a word, and this word does not composed of any letter. So it might be, if you get idea, uh, in C++, when you start learning this programming one or in programming two somewhere, and you took and you did the file IO operation, and you read a text file programmatically by using the C++ code, and you reach at the end of the file EOF. So EOF is you never see end of the file, but this is your something which is implicitly there in your that text file, and C++ can read that, but you cannot see that. So this is kind, or space. So, but space is a letter, space is not a word, but end of file is very best example for this. So this is a word, okay? Lambda is that kind of word. So what mistakes you will do? You will forget that lambda is word or letter. So you will see, because this is one character, and you will say, oh, this is letter. No, this is not a letter. This is a word. And this is a word which does not have any letter. Okay, it's combination of some letter, something, but it is not, those are not letters. So then we have a language, a set of words formed from the alphabet. So we combine all these words and we make a language here. So these are some terminologies which you need to understand, that what is alphabet, what is letter, what is word, what is lambda, what is language. Okay. So any question here? So Nikhil, any question here?
No, it all makes sense to me currently. I looked over this slide like when you originally posted it.
Okay, that's great. So, okay, so now we are saying that, let's see the comparison of this with English language, as I already did that. So you have your summation is your A, B, C, D. This is your all alphabets, and each member of this alphabet is your letter. And you combine these letter, you make word. You combine these words, you make language. Okay, so this is basically your example of English word. And now if you make sentences, let's say, so then your alphabets will be your words in the dictionary, and then you have the letter is your each word. So now we are saying that we want to make sentence. So now we are saying, okay, so in this case, might be my summation is, so my summation is equal to words, all words, okay, few words, let's say. And then my letter, so each word will be behave as a letter, okay, and then I combine these words, uh, and I will make the sentences. And the language will be all combination of sentences will be my word. So what happened that sometimes if you are dealing with something and that is not very complex, uh, you do not start making your language from scratch, from letters. Okay, so you start making your language from words. If you, because let's say if I say that I am not performing, I want to create a language, and that language is not very sophisticated language, it will not perform very complicated job. As I mentioned last time, in auto industry, I want to create a language which will perform only this job: hold the object, move up, move left side, and come down and drop the object. So how many words I need? Hold, one, move up, second, move left, third, drop, move down, four, and drop, five. And then number six, park your handle, so it will come back, so handle come back again to this location. So seven words, that's it. So I am my robotic arm is performing these uh, this job, and this job is combination of seven words. I arrange those words and I make a sentence. So in this case I do not have letters. I do not have basic characters. So I start making from the word, and then I arrange those words so that that word will be my summation. So I arrange those words in a certain order and I make a sentence, and then that's it. So I am not doing any sophisticated job. So when your languages are not very complex, so you do some compromises, and instead of like English language, start creating a word from letters and then um, alphabet, from then words and then sentences, and then so instead of that, you just start making your basic symbol is your word, and then from word you make sentences and the language. Okay, so that depends what kind of scenario you are dealing, what is the context, and based on that you will do this. So now this is one example, two examples I show you about the languages and how we use the alphabet, letter, word, and language. Most important thing you need to understand in this, that whenever I refer to alphabet, I am talking about summation. Whenever I talk about letter, I am talking about any single member of this set. And whenever I am talking about word, I mean the combination of these letters here. Okay, so more than one letter or one letter. And whenever I am talking about a language, so combination of the words that will make the all the this will make your sentences and the language. Okay? That is very important. You need to understand. So two words are considered the same if all their letters are the same and in the same order. So two words are same if their letters are same. So let's say if we have two words, and which is A, B, B, and then another word is A, B, B. So they are same because they composed of same number of letters, one, two, three, one, two, three, and the order is also same. Okay, so if order change or something minor changes, so this will not be the same word. So there is a difference between the word that has no letters lambda and the language that has no words phi. So now this is very important concept. This is also one of the very important concepts. So you will see, and people confuse always lambda with the phi language. So when if I have a language, and let's say my language name is L, and it has phi lambda there, and I have another language and it has phi there. So these two languages are not same. The first language is composed of this language is composed of one word, and that word is lambda, because lambda is a word without any letters. So it is not any empty language. So it does not mean that this language has no word or it is not performing any job or it is empty language. No, this is not an empty language. It has at least one word which is lambda, and that's separate story, that the word is without any letters, but still this is a word. But when we say your language is equal to phi language, so then it means this language does not have any single word or letter or alphabet. So it is a phi language, it is empty language. It does not have any word there. So now it means that lambda is not equal to phi. Okay, so this is a difference between that. So it is not true that lambda is a word in the language phi, since this language has no word at all. So lambda is not the case of the phi language. Lambda is a separate thing. It is a one word without any letter, and phi means this language even does not have lambda. It is nothing. It has not a single thing is member of this language at this time. Okay? So this is a difference between lambda and the phi language. Okay. So I am keep moving, guys. So please, let me interrupt me if you do not understand any single concept here. So if you are good, okay, then I can move to the next slide. So now we are saying that if you so there are two ways to define the language. So to list off all the words or set of rules and grammars. So let's say my language, as I mentioned, sometimes are not very sophisticated. So it is just dealing with two words. So I am saying that, okay, this is my language, and my language is composed of one word which is a b and the another word which is uh, a b b. Let's say I have only these two words in my language. Okay, so this is not summation, this is language. So now if I ask you what is the summation of this language, so summation is what are the basic building block is a and b. If you see that these are only two letters, and how many letters we have two letters, a and the letter b. And what is summation? A comma b. And what is the word we have two words. One is AB, one is ABB. And what is this language? This language is combination of these two words. Okay. So now, if your language is not very big, 5 words, 100 words, 10 words, so you can just write all the words of the language to define the language. Okay. If I ask you, can you please write can you define your language? So then you said, okay, my language is just 2 words. This is my language. But if you are talking about English language, let's say, or some language which has infinite words, we cannot predict all. Let's talk about the English language. We cannot predict all possible words of English language or all possible sentences of English language. I mean, it is infinite in nature. So you can make infinite sentences by using English language words. So in this case, when your language scope is very big, so it is hard to, and it is not possible to write all possible sentences or the words of the language. So then how you define a language? So then we will create a rules, and that rule is equivalent to the grammar in English language. So like English language, so you can make any sentence, but then you need to understand that this sentence should be according to the rules and regulations of English language. So now if I make a sentence, let's say a boy is he. And full stop. Oh, and I put, let's say, full stop here after boy. So now if you see that it contains all possible valid words, and basically I want to write he is a boy. And if you see, it is composed of the same words. All words are valid. But the how we know that this is not a valid sentence? English language, English grammar. The grammar of English language tell us that this is combination of valid words, but the arrangement is not valid. So rule says that you always start with he, and if these are the words, then is will come, and then a, then boy, and then when you finish your end your sentence, then you will have a full stop. So this is the how we know that we have these rules set by English grammar. So then grammar will validate our sentences, that this sentence is according to the rules and regulation of in this language or not. So then we can say that if your language is infinite in nature, infinite in nature. So then the grammar will validate, will use to define the language. Okay, so we have a set of rules. So we will see that how we create a grammar. That is the next part of this course. But now here you understand this thing. So the alphabet is always, so now some facts. Alphabet, your summation, this will never be infinite. It will always be finite. The set of words, how you make this alphabet, the set of words. uh, so you are saying I want to create a language which can always start from letter A, and then I don't care after that what happened. So you can make as many words as you want, so the words will be infinite. Okay, so in this course we will take care of the syntax. We will not take care of the semantics. So semantic means the meaning. So we will not take care of that. So I will show you this more in incoming chapter, okay, incoming slides. So what kind of rules are permitted? So it must be possible in finite time to determine if a word is in a language or not. So yeah, so we should create an algorithm which tells us in a limited time that whether this word belongs to this language or not. Okay, so this will be our algorithm. This will be our code, our program, our set of rules, which will define that whether this word is a valid word, it belongs to this language or not. And it should not take forever time. It should be possible in limited time because it's a very high in computation cost, and it will be so many words which you need to verify, so it should not be time consuming. Okay, so these are the rules. So main thing you need to understand here, that what is the difference between when your language is finite and when your language is infinite. Okay, so if you understand this concept, so then we are good. Guys, if you see that I'm trying to go very slow on these slides, especially this chapter and the coming 2 3 chapters till chapter 4, because these are the base of this course. If you understand that, you will be happy with the whole semester. Otherwise, if you don't understand here, trust me, you will struggle. So please let me know if you have any question in any slide. Anytime you can interrupt me and ask me a question. If you or you write a question, whatever the way you like. Okay. Now we are saying that we have this example here. So let's see, we have this summation is equal to x. So now our alphabet, this is our alphabet. So summation is equal to x is my alphabet here. And I create a language. And I am saying that this is my language, L1. And it is composed of these words. So every single thing is one word. Okay. So this is word. So I can write in this way. Or if you see that I am saying I can write this in algebraic way also. In algebraic expression, I am saying that my language is composed of letter x, and x has is raised to power n, where n is any number from 1 to onward, any number. So it means that you can use this x with any combination of itself. It can be 1, it can be 2, it can be 3, so any combination of that. Okay, and you can define. So now, so this is, you see here, three ways of definition of the language. This is your first way of definition, by writing all possible words of the language. You always start from the small word, and then you show the pattern, and then you generate some few more words, and then you put dot 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 and show that all remaining words will follow the same pattern, and this way you can create all future words. Or you can use this algebraic expression of define the language, or you can use this English sentence of defining the language. Any non-empty string of alphabet characters his word. So this is, so now you should be very concise and complete when you define your language in English sentence. It should not miss, it should cover all possible words of the language. It should not miss any single letter of of your language or any single word of your language. Okay, so whenever you write, you should think in a way that it should be so complete, it should be so concise that not a single letter, regardless this language will be infinite in nature, will be missed. That's the idea behind that. It does not matter that you write one line English sentence or two, 3 lines English sentence. Whatever, how many lines you want to take, you can take that. It does not matter. So now, some more concepts, some more basic concepts, basic. Uh, you might know all these things. Concatenation, when you combine two things, so it's the same concept is here. So two words write down side by side, a new word is formed. So you have one word which is XX, and then you have a placeholder A. You can say it is a variable, and you store this X into that, and then you have another word XXX, it's stored in another placeholder. You combine these two placeholders, and this way it is called concatenation, and you create a new word which is 5x's. Okay, so now this is one thing. And then factor means when we have a word, we want to see that are we able, so what are the alphabets, what are the letters we use to combine and we make our word. So let's say um, in this case, let's say if I have um, summation is equal to x, and I make a language and I have two words x x x x x. Okay, let's say this way. Summation is not x, summation is 2x and 3x. Okay, and I make a language, and this language is x x. It has a one word. So now I want to know that whether this word belong to this language or not. So how we know that? So what we will do, we try to break, because when if how we know that this word belongs to this language, if we figure out that we use all the basic building block of this language. So now we make a factor of this word. So we are saying, okay, let's make factor this way. Divide this word into two parts here. I do not have x there in my summation or 4x in my summation. So looks like this way of factorizing is not good. Let's divide this here. Yes, there it makes sense. I have 2x there and I have 3x there. This shows me that I combine these two letters and I make my one word, which is this word. So now this way of factorization is good. So this is the process of factorization when you break your word into your basic building blocks and and prove that these basic building blocks are part of this language, and this shows that this word belong to this language. So now one word, maybe if you see that you can divide this word into, so let's say I make another factor, I divide from here. This is again a valid factor, 3x here and 2x. So it means that one word, it may be factorized in more than one way. So you can validate that word in more than one way. Okay. So now we have this language here. So this language says my summation is equal to 0 to 9, and what and I so this is my basic building block. Just by looking summation, you cannot predict what is this language. It will just tell you whatever the language it will be, it is composed of only these building blocks. That's it. It will not, you will not see A there. You will not see B there. Only you will see whatever in summation. That's it. But just by looking at summation, you cannot predict that what is this language. So now I have this summation, and can anyone tell me that how many letters I have in my summation? someone. So Riley says that in this example, yes, in this example, XX is a letter. I have two letters. Exactly, you are right. Riley, is this answer of your question? Do you understand this? Very much. And very nice. Yes, it has 10 uh, letters here in this mission. And now I am saying that I want to create a language by using these letters, basic building blocks. I'm saying that words. Okay, so we have 10 letters and alphabet. This whole thing is oh, oh, this whole thing is your alphabet, and it is denoted by summation. And the language, I'm saying words that do not start with the letter zero. So it means I will never see a word which start with letter zero. So 01 is not the member of this language. 10 is the member of this language. 11 is member of this language. 21 is member of this language. 02 is not the member of this language. It will not start have any word which start with zero. Okay, so it explains you these things. Words that do not start with the letter zero. Very good. So now we are saying that, let's go to the next slide. Yes, this is the next slide. So number of letters in a word. So if you have the length is the function, you already saw that in different languages. You might be saw this in Python, in C++, in C, everywhere. So this will count how many letters you have. It is five. So now if you count 1025, it will be four letters. But if you count lambda, so you will see it will give you zero, because what is lambda? Lambda is a word without any letter. It will not give you one. It will not count one, because lambda is just a representation of that word. But implicitly, it means this word does not have any letter. It's an empty string. Okay. But this is still a word. It's a word without any letter. So that's the reason that when you find the length of lambda, it will not say 1, it will say 0, because it does not have any letter there. Okay, so then you have reverse operation, so it will just reverse your string, your word. You understand that. So palindrome is a concept where you have a word and you can read that word from left to right, or right to left. It will read same. And we have one country name also which is based on the palindrome. So let's say TIBIT, Tibet. So if you read from here, it will be Tibet. If you read from here, it will be Tibet. So this is palindrome. So does not matter you read from right to left or left to right, it will read same. So now we are saying that our summation is equal to a comma b. So now you need to understand one thing. By default, in this course, if there is if it is not mentioned that what is summation, so by default summation is equal to a comma b. This is the case in exam, in quiz, everywhere. If I mention, it's good. If I do not mention, you should understand I'm talking about summation is equal to a comma b. Okay, so this is the default assumption for this language. Now we are saying that summation is equal to a comma b. Palindrome is equal to lambda, and x reverse x is equal to x. So we write the algebraic expression. So now if you see this in this language, we explicitly mention that this language is composed of um, all possible words, and in a way all those words which you write, and if you reverse them it will read same. Beside, you are saying that lambda is also a word in this language. Okay, so you need to mention explicitly in all languages that whether lambda is part of that language or not. If you do not write that explicitly, the common understanding is you want to say that lambda is not part of this language. So if it is not, so then you do not write that. But if you write, if it is part of this language, so the way you write, you need to mention that explicitly that lambda is part of this language or not. Okay. So now if you see this, it says that all possible words, if you reverse them, it will remain same. Now if you see all these words, if you reverse them, it will read same. A or B or two A's or two B's, three A's, ABA. So all these are the possible words which you make, and it is infinite. So you can make any length of the word by using summation is equal to A comma B basic building block. Lambda is part of this language and it can be reversed. Are we happy so far? Are you guys there? You guys listening? Very good. Okay. So if you are there, that's nice. Thank you very much. So now we are saying that let's go to, so okay, this is very important concept, very important concept, clean start. You will see this clean. If you understand this concept, you can say that 20% of this course is done, because this is one of the thing you will do the major mistake in your exam one. So this, if you understand this thing, it is a very big thing. You can say that. So clean star is basically your clean closure property. So you are saying that closure of an alphabet summation is clean star. So you are saying given an alphabet summation, the closure of summation is represented by star. So we do not know that what is closure, but whenever I ask you find the clean star or clean closure of any set of any alphabet of any language of anything, so it will be represented by star. So star is a symbol to represent the closure property. So this is one thing. Now what is this? Is the language containing all words made up of finite sequences of letters from summation, including the empty string lambda. So we are saying that whenever we have this summation is equal to x, and I ask you apply the clean star on this alphabet, okay, on this summation. So it means that you need to find all possible combination of these building blocks, all possible combinations. So x, so how many letters we have? We have just one letter here, x, and this is your summation also. So when you apply clean star means that all possible combination of x. So what are the all possible combination? 1x, 2x, 3x, all possible combinations. So dot dot dot. Beside, regardless you have lambda here or not in your basic building block, lambda will be part of this language. So this is basically your clean star property. Okay. So let's see this in another example. So you have this 0 1. This is my summation. So if you want to find the clean star, all possible combination of this alphabet, okay, all these letters. So what are the possibilities? You might have 0, you might have 1, you might have 0 0. It's combination with itself, 1 1, combination with each other in different. So 0 1 is another, you know that order matters here. 0 1 and 1 0 are two different words, and then you go to the three letter 0 0 0, and this way you can make as many all possible combination of these alphabets. Beside summation, a lambda is also part of this language. Regardless lambda is there or not, it will be part of this language. Okay. So now that's idea for this closure property. Any question in closure property? Okay, we are happy. So then if you are happy, then no problem. So now we are saying that this is our closure property, and let's see what is about ABC. So if you have summation is equal to ABC, so we are saying uh, summation, then our language is equal to summation star is equal to uh, lambda, all possible combinations, A alone, B alone, C alone, A with itself, B with itself, C with itself, A with B, A with C, B with A, B with C, C with A, C with B, and then move to the three letter and all possible combination, all possible permutation. Okay, and the lambda is also there. So this is basically your language of clean star of your this mission. I hope you guys understand this thing. Okay, so this is your clean star. And now you are saying that let's see the definition of this, the of formal definition. So let S be a set of words. S star is the language formed by concatenating words from S, including the empty string, null string, lambda. So all possible combination, but it includes the lambda. So there is one scenario I want to discuss with you. Let's say if you have a language and your language is composed of lambda and x, and we are saying that we want to refine the clean star of this language. All possible combination of this thing. So lambda, so here you will have lambda there as part of the basic building block. So lambda x, all possible combination of x. So there is another property of lambda. Let me tell you. If lambda concatenate with any other letter or word, it will vanish. So when lambda combined with x, so we can write this, and later when you simplify that, lambda will vanish and you will only find x. So that's the reason that we do not write lambda with anything here, because if you have lambda, and lambda can concatenate with itself, so it can also vanish to, and it will only remain. So might be you have two lambdas here, you might be have three lambdas here, but all these will, and when you simplify that, will give you just one lambda. So that's the reason that we do not write this. So all these possible combinations. So now, so if you have lambda there in basic building block, then there is no problem. We just find permutation, all possible combination of the letters. But star gives you guarantee that rather lambda is member of your summation or not, it will be in the language. Okay, so it is not here. If you see, lambda is not here, but it is here. So this is the property of star. Star gives you guarantee, regardless lambda is member of your summation or not, it will be part of your language. Okay, so lambda, so star will bring that by itself. So this is basically your clean star. So now we have this language here, S is equal to a comma b, and we are interested to find the S star. Okay, so now I have this question with you. Anyone can tell me, can we have B as a word in this language? Anyone? Okay, Riley says, is all clean stars expansion in? Yes, all clean star expansion to infinite sets. You are right, Riley. Very nice. So Why does clean star always bring lambda? So guys, if you speak, so you know what, then you also help me to wake me up. So sometimes I miss because I chatting is somewhere here and I miss your question. So if you write and I do not answer your question, so please use your mic and ask me a question. I do not like Riley ask me a question, but somehow I did not see the chat and I just see now and I'm answering your question. But please, if I do that, if I miss, you can use a mic. I have no problem with that. Please, I appreciate if you talk because I like the this verbal communication. So why does clean star always bring lambda? So this is property of clean star, Quinton. That this is the basically clean star. That clean star gives you guarantee that lambda will always be part of your language. So this is basically regardless. This is in your basic building block in alphabet or not. But when you apply clean star, so it will bring lambda there. So that's the property of clean star. So what is the logic behind that? Why Clean Star is doing this? We have no idea, but this is what Clean Star is doing. So it is doing that. So now B will not be part of this language. So why B is not part of this language? Because you do not have B as a basic building block, and that's the reason. So because you create all the words from all possible combination of this thing, and you will never have only B as a word in your star because you always do all possible combination of your alphabets and you do not have only B there. Whenever you have B, you will have A with that. So that's the reason here. Yes, you can have only A here. You can have more than one A if you combine these A with itself. You can have uh, A B if it is a combination with itself. You can take first A and then the second alphabet letter AB. You can have A, B, and then A, but you will never have only B here. Okay, so or you will never have a word which start from B A like this thing. You will never have that because you do not have. It is not possible here. Okay. So this is some observation which I like that you should understand. Uh, and now we are saying that we want to make a factor. So we are saying we have this word and we want to know that whether this word belong to uh, is this word is belong to this language or not, because this is infinite. So somewhere here we have this word, we want to see that. So how we know, how we figure out that this word will be part of this? If we make a factor of this and we can break this into this thing, so then we can say that okay, this is member of this thing. So now if you break a b a b a b and a, so you see that you make the factors here and all these things are member of your S. So this shows that this word is member of this. It is a valid member of this because you successfully factorize that into basic building block. So we are saying that if you want to define this in English language, so S star is equal to, so like if I have this thing, if I ask you, can you please write the English description of this language? So the English description of this language says that this language has lambda plus all sequences of A's and B's except those that start with B and those that contain a double B. So this is the valid English description of this language. Okay, so this will not, it is not possible that you will have any word which is start with B. It is not possible that you will have any word which has two B's there. So that's the English description of this language. So do you see that how concise and compact this English description is? It gives you this information that lambda is also there. Beside, it also tells you that um, no word will start from B, or you will not have the two B's there in this language. Okay, so that's the idea behind that. Is the factoring always unique? No. You can make more than one factor of the same word, and that's also possible. I already show you this thing here in somewhere here. You see here, I showed you here that you can make this word into this way. It is a valid word, or you can divide this word into uh, here. This will also be a valid word. So you can have more than one factor of the same word, and that will be valid. Okay, so we are happy with this. Let's go to the next slide if you do not have any question.
I do have one question.
Yes, please go ahead.
So for this part right here, S is a group of words, right? So A is a word and AB is a word.
You are right. Yes,
Okay. So then um the clean star of this is the set of
all words
all words made up of the words A and AB.
made up of the letter A and letter AB. So
Okay.
this is a letter here, letter A and letter AB, and
Okay.
actually, this is a word here. It is not a letter here actually, because
Okay.
how we know that this is a letter, because you can see this. This is I. It is equal to S. Yes. So how we know that this is not letter, because it is not equal to summation. So summation is equal to A comma B.
Okay.
Okay, summation is your basic building block, and from summation you make another language S, which is composed of two words, and then A and AB, and then you apply clean star on your language, and you get another language, which is S star.
Okay. Gotcha.
That's
Okay. Thank you.
great. Thank you. And then we are saying that so it is very important that you need to see that whether it is equal to summation or any language, any other thing. If it is equal to summation, then this is basic building block. Yes, but in case of S, this is also basic building block, but these are not letters, then these are words. If it is summation, so then these are letters. So you are right that these are words. So now we are saying that, okay, factoring is not unique. I already show you that. This is the same concept. So you have, so now this S is equal to this thing. This is your language, which has two words, XX and 3X. And you apply clean star on your this language. And you are saying that whether this is a valid word for S star, we need to figure out. So we said, okay, let's try to make a factor of this. So we make a factor of this. We said 2x, 2x, 3x, and yes, this is a valid factor. We break this into the basic building block. And we also make factor by this way. This is also valid this way. So you see, the same word, we can break that into three different factors, and all are valid. So it is S star is equal to lambda and all sequences of more than 1x. So if I ask you, can you please, if I apply S star on this one, what will be the language? Can you write the English description of this language? So then you should say yes, S star will have lambda and all sequences of more than one x, because you see, you will have 2x here, you will have 3x here. Combine these two with itself, you will have 4x there. Combine these two with each other, you will have 5x there. Combine these three with itself, you will have 6x there. So this way, 6, 7, 8, you can combine, you can have all possible combination. Only thing is missing 1x. 1x is not part of this language. Other than that, you will have all possible combination of the words in this. So this is the compact definition. English description is that lambda and all sequences of more than 1x. So this way you can define this language. Good.
Yeah, we're good.
Okay, that's great. That's great. So we are happy with this. So let's go to the next slide. So we are saying that, okay, uh, here, if your summation is equal to 5, so then, so now this you need to understand this thing. This is also very important. So we have this summation is equal to, oh man, whenever I start, it goes to the next slide. So we have summation is equal to phi language. And I ask you find the star of this one. So phi means nothing. It does not have any basic building block. But when you apply star, clean star with regardless you have lambda here or not will bring lambda, at least lambda there. Yes. So this is what it is saying, that if you have summation is equal to phi language and then you apply the clean star of that, this will be equal to lambda, because uh, clean star by itself will bring lambda. Okay, this is the property of clean star, but it does not but besides your summation is equal to phi language, it does not have any a, b or anything else. So that's the only word we will have, which is without any letter. But now so this is one scenario. Okay, so now we are saying that if you have s is equal to, so I delete this. Okay, it is already written there. So if you have a language s and this is equal to lambda, s star will also be equal to lambda. But this is not the same case, the case which is here. Why? Because here you have s star is equal to 1 lambda, 2 lambda, 3 lambdas, 4 lambdas, and so on. But because this is the property of lambda, if you have 2 lambdas, it will concatenate and it will give you just 1 lambda. 3 more than any number of lambdas, it will give you just 1 lambda. And we do not write the duplicate terms, and this will equal to just lambda. Okay, so now because of this, we can say, so now this is a different thing now, you see. So it has whole this big set here, but in this case it is just only one lambda there. That's it. It does not have two lambdas or something, but end result is same. But if you see the logic behind that, the concept behind that, so these two things are not same. So but the end result is same. So regardless end result is same, so that we can say that if s is equal to lambda, then s star is equal to this because of this. So this is not the same case. You see here, I mentioned this thing. Do you guys understand these two concepts? What is the difference between this thing and this thing? Okay. So the clean closure of an alphabet summation always produces an infinite language use unless lambda is empty. So it will always give you infinite language. So I already answered this question. Only for infinite languages, the clean closure of two sets can end up with same language, even if two sets started with were not. So we are saying that sometimes you have two sets. Okay, let me clean this. You can see this in video. Is recording. So what we are saying here, that in the second thing, that let's say we have two sets here, two languages. We have one language S, and this language is composed of three words A, B, and AB. And we have another language T. This language is different from this language. These two languages are not same. If you see, because it is composed of A, B, and BB. So this word is different. See, the last word is different. So if your word is different, it means that two languages are not same. But it is possible when you apply closure property, star property on these two languages, the resultant language will same. So S star will be equal to T star. Now, if you see this actually, uh, if for this, so we have this word. So this is possible. Regardless, your basic building blocks are not same, but when you apply the star property, the resultant languages are both same. It will be just whatever the S star, it is equal to T star. They both represent the same language, let's say. Now, how we can prove that? This is not it. We are not saying that this will be the case every time. We are saying that this might be a case. Okay. So now you have this word here, A B A B. So this is our one word, A B A B and A B and A. Okay. So now if you divide this word into A B and then A B A B. So now the and A. So if we successfully make factor of this word of this language, and now if you divide this word into make a factor after every letter like this. So still it is good, and it satisfies this language also, because it means that I only use this letter and this letter, and I make this word, because it's not necessary that you can use all three words or of your language. You can combine, so any one word itself with any other word, or all words can combine with itself. So this is, you make factor of this, and you reach to the basic building block of this. So now this satisfies, this way of factorization satisfies this language also and this language also. So this shows that this word belong to this language and the previous language also. So we cannot figure out that this word is from which language. So it is composed of both languages. So you see that regardless, two languages are different from each other, but the word which we will create satisfies both languages. So this is a possibility that if your languages are not same, but you apply clean star, it will be the same thing. The clean closure of a language S always produces an infinite language unless S is equal to phi or S is equal to lambda, in this case S star. So I already explained this to you. Okay. Now we done that thing. So now we have a new concept. So any confusion with star. Otherwise, I want to change the topic. I want to go to the positive closure. Any confusion with the clean star. So are we good? So Riley, are we good? Do you understand this concept? Very good. Okay,
I'm good too.
that's great. Thank you very much. So let's see now the positive closure. So positive closure is basically how you define that. You use the positive sign, whether you use this with the language or you use this with the summation. Again, it will be on this exponential position. I put it here, so it should be corrected. It should be here. The language with all concatenation that contain at least one word from S and one letter from summation, S star possibly without lambda. So now this is basically very interesting fact. It says that positive closure says we will not add anything by itself. Whatever your basic building block, we will perform the clean star of that. But what clean star will do? Clean star says if summation is equal to x, summation star is equal to lambda x, 2x, 3x, dot, dot, dot. It will add summation by itself. So positive closure says, no, I will not do that. I agree with clean star what you are doing. You are doing all possible combination of the basic building block. But why you are bringing lambda there from nowhere? So positive says, I will not bring anything from myself. Whatever will, if lambda is there in your basic building block, I have no problem with that. You can write lambda there. If it is not there, please don't write. Just write. So now, if I say that lambda is equal to, summation is equal to x, and find the summation plus of this thing, so it will be no lambda here. There will be no lambda here. Just all possible combination of x with itself. So this is the difference between positive closure and the clean star. So now what is the difference here? Let's say if your summation is equal to lambda and x. So now you see lambda is there in your summation here. So in this case, if you find the positive closure of this thing, so then this will be lambda x, 2x, 3x, and so on. So when you have, so we can say that uh, that S star, if lambda is, so now you can understand this word, this line. If lambda is a member of S, then S star is equal to S plus. Otherwise, otherwise it is equal to lambda minus S star. Okay, so this is basically what we are saying. If lambda is member of S, then S star is equal to S plus. Then there is no difference between the positive closure and the star closure. But if lambda is not member of your S, so then uh, if then you will not see lambda in your language. So positive closure will not bring lambda by itself. That's the only difference. That's it. Otherwise, it is same. So now, if you see this, so the positive closure of this language is same. No lambda. S lambda is here, so it will bring lambda here. Okay, and all possible combination of A and B with itself. So that's the only difference here. That's it. Are we happy with this? Are you good to find the difference between star closure and the positive closure? If you are happy with this, it means it's a big thing you understand. My experience says that students will do mistakes here. They do not understand this concept because you will use this concept uh, very much in chapter 4 5, so very much, and all that, so they actually depend on this concept. You should understand when you have plus sign, so and when you expand that language, what should be the part of that, and when you have closure property and when you expand that language, what should be the final output. Okay, so you don't have any questions, so it means that you are happy with this. So now we are saying that let's go to this thing, theorem. For any set of word S, we have S double star is equal to S star. So what we want to say here, that once you find the closure property, then it does not matter that you find again closure or you find again closure, because it is same. Remember, there was one guy in chapter 1 we study, he said that infinity comes in different sizes. So this is not the case here. Actually, infinity is always be of one size. So now if you, and you know that S star is infinity, it is infinite, all the infinite words of that language. So when you apply 2 star on this one, this will be remain same. It will not change the infinity. It will again infinite. Okay. So this is basically what we are saying here. And now how we can prove this? We are saying that if your, so we can prove this by some set theory, and you saw that equality of sets, if S is subset of T, all members of S is in T and all members of T is in S, So it means that S is equal to T. So this is what we are saying. So now S is member of T for all X in S, and X is also in T. So now, so if you see this, we have this is your S, and you apply clean star, and you are saying I have these words which is in clean star, and then you apply, you have one word which is a. So this is another word which is very big word, A, and you are saying that this is part of S double star. So if it is part of S double star, it should be part of also S star. And now you see this is part of S double star. And now if we break this into these factors, look at this one. So we break this into this factor, and then we break this into this one. So we prove that this is from S and this is from S star. So look at this one. We break into those factors. Now, if so, this shows that regardless, if you have one star, and if you on that star, if you apply another clean closure property, it will not make any difference. It will the language will remain same. It is because all there is no different sizes of infinity. Infinity comes in only one size, which is infinite. That's it. Make sense? Do you guys understand this? Uh, if you understand, so please write yes, no, so I know that you are there. Very good. That's nice. Thank you very much. So it is very important, guys, because we are not used to of this online session. So it's very easy to get bored and get sleep in this. So I always appreciate that if you use mic. That's the concept behind that. I am taking the live session because for me it is very hard to just talk and without any interaction. So if you guys talk with me, so that also motivate me, and I can wake up and I get more energy that you guys are listening. Okay, so now if you are happy with this, so let's see this. We can prove this by some proof method here. So we are saying that S double star is equal to S star. So now you see so we prove this by equality set. So if S double star is subset of S star, and S star is subset of S double star, exactly you see this in this slide here. Look at this one. So it means that S double star is equal to S star. So we prove this. So let's take one first case. Every word in S double star is made up of factors from S star. So every word, because if you are applying double star, it means that you choose this as your basic building block. Okay. So it means that this is your basic building block. Then if you so every word in S star is made up of factors from S. Therefore, every word in S double star is made up of factors from S. So therefore, every word in S double star is also a word in S star. So this is true here. And now, if you have case two, so you are saying that in set A we can show that A is subset of A star. So let W be a word in A, then W is certainly in A stars. So now, if you apply this on the next step, so if we consider S star as our set A, we can conclude S star is subset of S double star. So because you prove that both things are possible, so this shows that S star is equal to S double star. So I mean this is very simple proof. It's not very complicated. You might saw these kind of way of proofing and somewhere in algebra or somewhere. So we did this. You already have awareness of this kind of concept, and um, and if you have any questions, so you can ask me. I can explain more. Okay. But this is very pretty straightforward. It's not hard. So we prove this, and I think that's it. So here we finish our this chapter, and it is very important to mention that I did not get any slides from this book. There is a distinguished professor, Dr. Amy Felty. She is in University of Ottawa, Canada. That's my mother institute. where I did my PhD and my master's from there. So I got this help from Dr. Amy Felty, but later I add so many material in those slides and expand them a lot. But initial slides were the source is Dr. Amy Felty. And beside after that, I used the second edition of this book, and this is also the one of the major source of information. So, so yeah, that's it. So if you have any questions, so you can ask. Otherwise, we are good. I will create a quiz. I will send you the announcement. So it will be so start preparing chapter one, chapter two. I will put the so you will have a quiz of chapter one and chapter two very soon. Might be if I created this quiz today, you will have this tomorrow or otherwise day after tomorrow. Will we be expected to do mathematical proofs such as no. Quiz will be just 5 minute quiz. MCQs, true, false, yes, no. That's it. Quiz is just like 5 minute come in, 5 minutes sit down, 5-10 questions. Options are given or true or false statement. You just quickly do that and we start the class. It will be something like that. No, I will not use Proctorio. I will restrict the quiz. You will not allow to change the answer once you done the quiz. Once you choose the answer of one question, I believe you are not allowed to go back. And then there is a restriction of the time. I will make it restricted according to my own understanding that how much time it should be. So you should be finished. Once you start, then you need to finish this in that given time, like 5 minutes or 7 minutes. Most of the time, I give 7 minutes. So this is the way. So now you need to understand that you are not allowed to change your answer once you finalize your answer. I believe you are not allowed, it will not allow you to go back also. So once you're done, you are done. So choose the answer wisely, take your time, and then it will be around 7 minutes. If I give you 7 minutes, it means that it is possible to do that quiz in 5 minutes. It will be online, and I will not give you any particular time slot. I will make it available from morning 8 to evening 5, any time in between whenever you get time. So you can do one, and this will be only one attempt, and you can do, and this will be you will done your quiz. You will not see the answer of that during the quiz. Even after the quiz, I will show you the answers. I will post the answers actually after that online. I can see that how we can do this. Okay, so if you are good, so then we are done. Any question here? Otherwise, I think that we are good.